so we're going to start by creating a new project, and we're going to have that as just a unit test project to start with. So we'll just give it a name. I'll wait for the hamster. Okay, we've just got a basic empty xUnit project. Before we go too much further, I'm planning on using Fluent Assertions. I'll be using JetBrains ReSharper. Obviously I'm using xUnit. So first thing is to sort out my NuGet packages. So Fluent Assertions isn't installed by default, so we just need to go and find that. And install. If we just look at what we can update, so may as well just do everything. Fast forward that. Reason I'm using Fluent Assertions for this is that it's relatively new to me, introduced to me by a friend of mine, Graham Elwood. So there you got your name on a video. So I'm just going to refactor some little bits of this just so it's named nicely before we start. You'll notice that on the screen I will be putting what keys I'm pushing to do the refactor. And that's just kind of an assistance to anybody who's new to keyboard shortcuts or what you can do with ReSharper and Visual Studio. So we're just going to zoom in. As we go through this, I'll make it pan about all over the place, so hopefully don't get seasick. But also hopefully you can see what I'm typing. So first kind of test is we just need to test for prime factors. So we're just going to test driven. So we've created the first function. I just need to put get on the front of that. Right. So we've created a function. We're now in a failing state. So we're going to introduce that function. So there we go. Function introduced. So we're now technically in a green state as I am compiling at this point as a unit test. So initially I'm not actually running any of the tests. Just going on compiles, doesn't compile. So I'm just going to change that to int. And okay. We can refactor technically, so we're green, so into refactor stage. Just do some simple, make it static. Okay. So next bit we need to pass something in. So what we're going to get the factors of in the first one. Easiest thing is factors of 1. And that should return an empty list eventually, but we're failing. So we've added that parameter in. Let's rename it using ReSharper, and okay, we're all green. So next step, we probably need to start looking at actually asserting something. So using Fluent Assertions, so is should, and then I can say be empty should be spot my obvious mistake there. That shouldn't be an int, it should be an enumeration of int. Everything to this point, we've been considering the compiler as kind of the unit test. So now we're going to start running the actual tests to affirm the asserts. So we should now be able to run this test, and that should give us a fail, and it does. So now we're in a failing state, we need to make it pass. Absolute easiest, simplest way is to return an enumerable that has no elements, so just an empty array in this case. Test passed. A green. Right. Is there anything we can refactor? Probably not. So we'll just clean at that point, so commit. The next test you can see here is factors of 2. If we look, that test is failing. So we need to do the simplest implementation or change here to make that test pass. So all we're going to say is if the number we're trying to get the factors for is greater than 1, i.e. it's not 1, we can return, well, effectively we're going to return a list of integers with a value in, and if it isn't greater than 1, we're going to return an empty list as we did before. So I'm going to use the extensions to IEnumerables to do an immutable append. So we're returning a new enumerable based on an empty enumerable with the value we're looking for appended, or we're just returning the empty enumerable. So if we run that now, it should pass, and it does. Excellent. So refactor, that looks awful, so we get rid of the braces. I can certainly tidy that up. So if we extract that to a function that returns us an empty list, just to make it readable. In fact, we can just call it empty list. Okay, now we can bring that, so yeah, that would be an enumerable. We can tidy that up, make it into a expression body. Let's pop that in a new line. We can, because we'll never do it twice, we can pull that in line, and then we can just refactor that to there we go, and make that an expression body. We can sort some tests out. So we're still all in one thing, so we'll have to sort that out at some point, but for it, we'll bring that in line. We just make this look nice and tidy. And yeah, okay. Do the same here. We can bring that in line. We can, well, do the same. So expression body that. New line. I can, yeah, we're doing the expression body this one, so we'll do that as well. So everything's looking relatively tidy. So okay, we're clean. So we'll commit at that point. Features in IntelliJ I found really annoying, so I'm going to turn it off. And seeing as we're doing a screen share thing, I might as well show you how to turn it off. So if you go into the ReSharper menu at the top, you can simply go to the options and turn it off. There we go. I'll apply that, and now it gets rid of all that grey goop that was in the middle. I'm sure somebody by now has noticed my very obviously stupid mistake here, then that in fact should be 2, and therefore that should be a 2 there. So now just to confirm, we can run the tests, and we're still good, so we're great. So start writing the next test. So we want to look at the factors of, well, 3 is the next number, let's do 3. So pretty much the same as before. So we're going to call the function get prime factors. We're going to pass it a 3, and that should oh, it should not be empty. And only contain, well, that should be, well, a 3. Let's just sort my typo there, and semicolon at the end. Good. So that's test. Let's run that, and it fails. We don't have anything that returns a 3. We've already got a 2. So the easiest way is just return the number we passed in. So let's see if that's made the test pass. And it has. Awesome. Didn't really do a lot, so there's not a lot to refactor. We can just make that an expression body, same as the previous ones. All good, I think. So there we go. Now look at this, we put this off long enough, so I'm going to extract the production code side of it, if you like, the actual implementation out as another class, which is sort of a first step in to get it into the right place, but probably in the real world this wouldn't be the end zone. But we're going to make it a static class because all the functions are going to extract are static. So that's all good in its own file. So now we've got a separation. So what we're going to do here is continue that refactoring and make this a static class, because our end game is to use this as extensions. We can just tidy up a few things before we get started, so we can put that to extension invocation. So we make this an extension, just put this in front. So that's now an extension of the integer. So we go back to the other side, and you see it's already highlighted in green, so we can change these to invocation, extension invocation, sorry. So we do that all of them. So now we get this notation, we've got the number and get prime factors. Let's put that on a new line, and we can just make that read the same as the others. So looking fairly tidy now, and all using the extension that we've just extracted. So commit at that point, we're all clean. Okay, on with the tests. So obvious next progression, find the factors of 4. Test factors of 4, and I'm going to use expression body straight away, and so 4, use the extension method, get prime factors, and dot should. So we'll keep the same ideas, so not be empty, and so we can't use only contain here because we're expecting 2 values. So we're going to use be equivalent to, and to use that we're going to pass in a array of integers, so the two 2's that we require, and there we go. We can get rid of that. It's doing a cheeky bit of refactoring when we shouldn't be, but hey. Let's run that, and we should see it. Ooh, fails. Right, let's go make it pass. So let's flip across to the other side. Now, as you can see, we've been nice and tidy, so everything's expression body here. So first thing we probably need to do is to kind of expand all this back out. So first thing, I'm going to take the function itself, take it out of expression body, then we're going to put the if statement back. Right, so we've got a more conventional structure inside the function, so we can move some bits of it about. Okay, so we're going to put some brackets around here, which we could have done by using refactoring functions. I've just done it a long way around for no obvious reason. So we need to check if it is divisible by 2. So number, and then we'll use the modulus of 2. And I'm going to check there's no remainder, so that should equal 0. So that's our check for is it divisible by 2. So we're going to remove the return and introduce a variable. Okay, we're going to split the declaration and initialization of that. And then we're going to move that to the very most outer scope. And then we're going to make it return the variable as opposed to an empty list. We'll come and rename that later. Okay, so I'm now going to take the empty list out of here, and this is a bit scruffy, but we'll initialize it here and then make enumerable return a new enumerable based on the current state. So we're going to append it to the current value. So returning first value, now we need a second one, which is a mutated. So we'll mutate number to equal number divided by 2. We can refactor that quickly. So now we've done that, we need to add another value to the enumeration, which is going to be the remainder, which is just number. Okay, we need to put that to 2, because obviously that's the factor we're actually dealing with, is 2. Right, I think that should work. So we'll run all the tests, because we made a fair amount of change there. Oh, we've got a failing test, but it's not the one we've just done, it's 2, and it's failing because it's got a 1. So, okay, let's go back to the code. And that's because we've got this remainder, so we just need to check if that remainder is, or the number in this case, is greater than 1. That's the only condition we should add it. So yeah, so that's nice, that looks like it'll work. Let's go back and run the tests again. So running, let's just move that across, and we're all passed. So we've got this code, and I think we can probably make this look and read a little bit better. So let's refactor it. The first thing I'm going to do is select this bit in the middle here, and I'm going to extract that as a function. So let's call that add factors, sorry, add prime factors, that's fine. So so we can make this now just return that, and then we can refactor this if statement. So we're now going to look at the function we extracted. We're going to change the signature of that, just to swap around the parameters quickly. So there we go, we've got the enumerable first. We can then make this an extension of enumerable of int, and then we can change this around so that it invokes it using extension invocation. So that's tidier in my opinion. We can just add carriage returns here, because that's how I like it to be. Because the instantiation of enumerable here to empty list is technically kind of irrelevant, we're never going to call it twice, we can bring that in line. So if we inline enumerable, so we use empty lists, it's never, both sides of that expression are never called. So it's only going to ever call empty list once as it goes through. So that's good enough. So we'll commit at that point. So let's go back to the tests. Next test, factors of 5. So test factors of 5. Expression body, and then 5, same extension method, get prime factors, should, and then we can just use the be equivalent to. So be equivalent to, and so that's a new array with, well, just 5 being a prime number. So we'll just run that and see if that passes. They're all good. So refactor. we can technically take all the not be empty and the and out, because they're not actually needed, and to be consistent we can change these to be equivalent to. And then we can take out the not empty and the and do the same thing here. Take out the not empty and the and, change that to so be equivalent to, and then a new array with just a 2. All looking fairly clean, so we can run the tests. Everything passes, so clean and commit on to our next test. Right, get to the bottom of the tests and add a new one in for test the factors of 6. So we're going to do the same thing as before using expression body. And then we're going to do the same style, so using the get prime factors extension method, should, and then be equivalent to new array, and then a 2 and a 3. So if we run the tests, oh, that fails. That shouldn't fail. Why is that failing? That's failing because I put a 5 there instead of 6. I'll learn what numbers are eventually. Now we know 5 and 6 are different numbers. Refactor, nothing to refactor, so we can commit and on to the next test. The next progression being test the factors for 7. So test factors of 7. Again, going to use expression body, same as ones above. Use the extension method, get prime factors, should, and be equivalent to new array, and then 7, as 7 is a prime number. So let's go run the test, and we pass. Okay, refactor. We've not really added any code, so next test shall be test factors of 8. Expression body again using the same extension, so get prime factors, should, and then be equivalent to, then new array of 2, 2, 2. Okay, run the test. Now that is definitely going to fail because there's nothing in what we've done so far that would allow for 3 values. So into doing some change. Now this is a very, very simple thing. If you watch carefully, we just change the if to a while. That's all we have to do. So if we go and look at the tests, they're all passed. So nothing really to refactor. On with the next test. So this one will be factors of 9. So in the same way as the above, create test factors of 9 using expression body, then 9 get prime factors, should, and then be equivalent to new array, and that's 3 and 3. So let's run the test. And that fails. So over to the code. The easiest way we can change this is to copy this while loop and change the divider, which is currently 2, to be 3. So it looks like that. So if we run the test now, that will pass. But that means the solution here would mean we'd have to add one for every single prime number, or every single number. So we're going to take that out, and we're going to introduce a variable for this divisor, and we're going to call that divisor. So we need to add a condition here. So we only do this if the number is greater than 1. We're going to do this while statement, so let's just move this in and put braces around it. So ideally we need that to be a while, because we need to do it multiple times, and obviously we need to increment the divisor, so we just put divisor plus plus. Okay. Now we've added the while loop. That means this condition here will always be false, because number is never going to come out of that loop greater than 1. So we can simply remove this whole if statement and the adding of the remainder, because it's no longer needed. So on that, if we go and rerun all the tests, they all pass. So I think that's it. We've got a algorithm that works. So all we need to do is commit there. So what we need now is one last test that tests something a little bit more complex or bigger. So we're going to create one last test and call it test factors of, well, we'll just call it big. Again, choosing expression body. Now we're not going to use a single number here. I'm going to, in parentheses, put a set of prime numbers multiplied together. So I'm going to do 2 times 2 times 3 times 3 times 5 times 7 times 11 times 11 times 13. Oh. So all those are prime numbers. So get prime factors of the sum of all that. And that should equal, well, the equivalent of the same list. So be equivalent to a new array of 2, 2, 3, 3, 5, 7, 11, 11, 13. Okay. Just missing parentheses off the function, so we can just run the test now. Suspense, all passes. So now we can go into a big refactor. attempted to do in that quite quick 4x speed refactor is to make this so that it's as close to functional as possible. So really what we've got is a relatively standard recursion, no variables being declared, and everything returns a new instance, so we don't have any mutation. I'm not saying this is a definitive version or that it's the best or even that I couldn't do better, but hopefully it starts to show how I approach things, and hopefully that might help you with your own endeavours. Thank you very much.